In the previous video, we mentioned some properties of area. Two of those properties are written here. One is that if two figures are congruent, then their areas are equal, and the other, if a figure is divided into parts, then its area is equal to the sum of areas of its parts. Suppose now that we have two figures, phi and phi prime, so that each is divided into n parts, and suppose that the corresponding parts are congruent. Phi 1 is congruent to phi 1 prime, phi 2 is congruent to phi 2 prime, and so on. Now, that means that areas of corresponding parts are equal, which in turn means that phi and phi prime have equal areas. Another way to look at this is that we divided figure phi into m parts and then moved and rearranged those parts to form figure phi prime. Dividing figure into parts and rearranging them is what we'll use in the following examples. This is a square whose sides are equal to 6. Suppose we want to find a rectangle that has the same area as this square, so that one of its sides is equal to 9. We can divide the square into smaller squares whose sides are 1, and then we have 6 times 6 smaller squares, so we have 36 smaller squares. And since 36 is equal to 4 times 9, in the rectangle will be 4 rows of 9 squares each. But the area of each of these small squares is equal to 1, so both the area of this square and of this rectangle are equal to 36. That means, at least in this case, for both the square and the rectangle, the area is equal to the product of lengths of their sides. And that leads us to conclude that if A and B are lengths of sides of a rectangle, then the area is A times B. But did we prove that this is the case for every rectangle? No, and we won't prove it, we'll just accept it. But we will show a potential problem that can arise. Just as before, suppose we want to find a rectangle that has the same area as this square, but now one side of a rectangle is 8.5. So we want to divide the square into parts and then assemble a rectangle from those parts. Pause the video if you want to try it yourself first. Now here is how we'll do it. Let this length be 8.5. And now we'll draw a line that connects these 2 points. If this length is equal to x, then we'll draw a horizontal line so that this is also equal to x. Let us denote these parts by 1, 2, and 3. If we slide parts 2 and 3 in this direction, we will get the rectangle that we want. This side of a rectangle is equal to x, but how do we know that 8.5 times x is equal to 36? Keep in mind that we shouldn't use that 8.5 times x is equal to the area of this rectangle, since we haven't proved that formula for every rectangle. And this is just one way of dividing into parts and rearranging them. We can generalize this question by asking how do we know that if we divide one rectangle into parts, and from those parts assemble another rectangle, that the products of their sides will be equal. This, however, we won't prove, and we'll just accept that the area of a rectangle is equal to the product of lengths of its sides. With that in mind, I leave you with this problem. Suppose sides of a square have length 6. Divide that square into parts, and from those parts assemble a rectangle whose one side is equal to 37. That is all for this video. If you liked it, click the like button, it helps with the YouTube algorithm. And I'll see you next time.